Hello, it's the IT Guys 99 here, and today we're going to be doing a complete tutorial on how to use the Python programming language. We're going to be starting from the very basics and working up to some of the more complex features of the language. So let us begin. We'll assume that you've already installed Python. I'm going to be using the Anaconda version of Python. However, in this tutorial I won't be importing any of the modules, so you can use the basic version of Python. There will be tutorials on how to install either the basic version of Python or the Anaconda version of Python on our channel. There will be a link in the description or a card on the top right hand side of your screen at the moment. So go and watch one of them if you haven't already installed Python. Now that we've got Python installed, we're going to open a PowerShell window. This is how we're going to get started, and we're going to start just by launching Python. We do this by just typing the command Python, and we can see now that we have Python started. We can tell that as we have these three arrows here. Now that we have Python, let's run our first command. We're going to first use the print command. This will output whatever we type after it to the screen, and we're going to type a string, and it's going to be hello world. As you can see, I've put speech marks around hello world as it's a string, and that's how we just tell Python that we are using a string. When I press enter, we'll see hello world is output. However, if we want to write more complex programs, it might seem quite clumsy to keep doing it within PowerShell. And this is how we will then start to use a code editor. I'm going to be using Notepad++, but there's several different code editors that you can use, and each has its own advantages and disadvantages. So we're going to leave Python by typing the command exit with parentheses either side. And as we can see, we've now left Python and we're back in our regular PowerShell command line. Now let's switch over to our code editor. We're again going to start by just printing hello world to the screen. So we can type print hello world. And again, remember to put the speech marks. And again, we'll explain a little bit more about different variable types in a minute. And we're going to save this file. We're now going to close our old PowerShell window and come across to the file location, wherever we've saved our file. I've got it in my documents in a folder called Python. Now hold down Shift on your keyboard and right click, and click Open PowerShell window here. And we'll have a PowerShell window open in the location of our saved file. It's very important that we are in the directory that our file is saved in for this to work. You could also use the cd command within PowerShell to navigate to this directory. So now we want to run our file, to run our code. I've called my file python tutorial.py. The .py extension tells us it's a Python file. So to do this, we'll first type Python, as this tells the command line that we want to run a Python script. Now we need to type the name of our file. So it's python tutorial.py and click enter. And we can see that we have printed hello world. So we have just run our first file from a script. Now let's discuss a few different types of variables that we have in Python. So we have strings, which we've met already. This is a series of letters and are encapsulated in speech marks, like this one. We also have integers, which are just whole positive numbers. So example, we could have 1, 3, 199, 2,500,000, etc. We can also have something called floats. So a float is any decimal number. So if I wanted 1.2 or 3.9, they are floats. we also have something called boolean. So boolean is either true or false. So we could create a variable which is either true or false, and that would be a boolean variable. And finally, we have complex numbers. So if you have never met complex numbers, they're an extension to the number line, which you want to see a maths course on why you would want to use them. But if you're familiar with complex numbers and you want to use them in Python, we do this by adding a j after the complex part. So that would be 1j, or often referred to as 1i, 3i. We could have the real and imaginary parts, for example 1 plus 2j, would all be examples of a complex number in Python. So now we know the different data types, we want to assign them to variables. We do this by creating first a variable name. For example, I'm going to say txt for text, and I'm going to call it hello world. We use this one equal sign to assign the variable txt to the string hello world. We don't need to declare the type of variable like you do in some other programming languages in Python. We can also assign, say, the letter A can be the number 2, and the letter B can be a float of 2.4. Again, with boolean, we could have, say, found being our variable, and we could make that true. We can always change a variable during our code. So if I want to then change text, so txt, to a different string, I could do so like so. This by typing the variable name and then putting the new variable. By typing the variable name and then putting its new value here. Now let's print some of these variables. To do that, again, we type the print command, followed by the name of our variable, like so. I'm using Python 2.7. However, if you want to use a newer version of Python, like Python 3, there's a slight difference to the print command and you would need parentheses. However, in this version of Python, we do not require the parentheses. Let's also include a second print command to print the txt variable again. So what we should see when we run this code is it'll say hello world when we print it the first time. Then we're going to change that variable to hi, and then the world will say hi. So let's run this script. And as we see hello world and then hi. We can also print the other variables, or a series of them, by separating them with commas. So if I want to print A and B, I can type the first variable name, comma, the next variable name. And again, let's run this. And we can see we've got 2 and 2.4 output after hello world, which is our first print txt. So now that we've looked at the different types of variables, we might want to start changing between some of the variable types. Okay, so now let's look at how we can convert between some different data types. I'm going to start by creating a string called A. Let's call this string, say, 1.2. Now I'm going to print the type of A, just so we can show that it's a string. And I do that by first using the print command. Now I type the function type, and then I include the variable name A. So now when I run this code, we can see it says type string. Now let's convert this into a float. So let's set our float to be the variable B, and I can then type the word float to convert to a float, and the variable A, which is what I want to convert into a float. And now let's print the type of B, and we'll see that it'll say string then float. which we can see here. So we've now converted b into a float. We can print b, just so we can see what we have, and we can see it's displayed as 1.2. Now, let's convert b, which is our float, into an integer. To do this, we can type c, which could be our next variable, equals int b. And this will now convert b into an integer. However, since b is not exactly a whole number, we'll have some rounding when we convert it into an integer. So we'll start off again, we'll print the type for c, and then we'll print c, and we'll see what we end up with. So we can see we've gotten from string to a float, it's still 1.2. Now we've converted to an integer, and it's been rounded down to 1, because integers are just whole numbers. Finally, let's convert this back into a string. To do that, we're going to go with d as our final variable, and we're going to type string, which is str, and then we're going to put c in here. Finally, we're going to print the type of d and print out d, and we'll now have converted it back into a string. So finally, we've got a string, and its value is still 1. So that's how we convert between our different types of variable. Next, we're going to look at some of the basic maths functions within Python. I've got two variables I've created, a and b, and I've given them both integer values of 10 and 4. I'm going to create a third variable, c, and it's going to be the sum of the two. So I can type the variable name for the first one, the plus symbol, and the variable name for the second one. And that's a plus b. I can now print c, and let's run this code, and we should see that 14 is printed out, which it is. Now, let's change this to subtract. To do that, we just use the subtract sign, and we should now see that 6 gets printed, which it does. Let's multiply. Now multiply, we use the star symbol, so it'll be a star b. We can save that, and now run it again. And again, we see 40. And now we're going to do divide. Now divide is special in Python. So when we divide integers, we'll get an integer answer. So we'll have the lowest integer. So for this one, we'll have 2, because 4 fits into 10 2 times with a remainder. So we'll always have a rounded down version of the division. So we can print c here, and we'll see 2. Oops, sorry, I didn't save it. So let's run that, and there we go, we can see 2. If we want to find that remainder, which will also be 2 in this case, because 4 times 2 is 8, which leaves 2 left over for 10, we can find the remainder by using this percent sign. So if we run this again, we'll also see that 2 is output, and this is now the remainder. If I want to use division, which does give me the exact answer, I need to use floats. I can change both of these to a float by adding a 0.0 onto the end of them, and they are now floats, or I can convert them to float using the float command like we saw earlier. So now if I run this code again, we can see that we get 2.5 as our answer. So we have now got the exact float value for our division. Let's also look at how we can do powers. I'm going to convert them back into integers. Now to do a to the power of b, I'm going to reduce b to 2 just to make it a smaller number. And we put 2 stars. So when we see a star star b, this is a to the power of b. So let's run that. And 10 squared is exactly 100. So there we go. So that's now given us our powers. Now let's have a quick look at how we can do this calculation and reassign to a variable in a quick and simple step. So if I want A to stay our variable name, I just want to add say 4 to it, or another variable, I can always use plus equals, say B, or I could put a number here, and this will take the value of A, add whatever B is, and then reassign it back to the value of A. So if I print A here, it's going to take 2n, add 2 to it because that's the value of B, and make A 12, and then I'm going to print out the value 12. So let's run that, and again we can see that has worked here. Again, we can do the same thing with subtract, multiply, or divide. So if I run A divided by B like this, reassign it to A and then print, I'm going to get the number 5 because 10 divided by 2 is 5. Next, we're going to look at how we can comment our code in Python. So lots of programs, when you're writing longer code, you'll want to add comments to help remind yourself what you're trying to do in each step. To add a comment in Python, there is 2 different ways. We can first use a hashtag, which is a single line comment. After the hashtag, you can write as much as you want, and it won't be run as part of the code. When you run your code, it'll just be ignored, and it's just there to help you remember. So if I run this code, absolutely nothing will happen because all that's in there is a comment. You can see nothing happened. If you want to have multi-line comments or doc strings, to do that, you put 3 of these single quotation marks, then you can put as many lines as you want in your comment, like so, and then as soon as you're done, put 3 more of these single quotation marks, and that will be the end of your comment. Now that's a multiple line comment, which again, when we run our code, will just be ignored by the code, and it's just there to help you understand what you're doing. It's quite good practice to put one of these as a doc string at the start of any module or code that you're creating, and also at the top of any functions that you are creating within your code to remind whoever's looking at your code what they are for and what that piece of code is trying to achieve. So next, we're going to look a little bit more in detail at what we can do. Next, we're going to look in more detail at what we can do with some strings. To start off with, we're going to create a string. I'm going to again call it txt. I'm going to assign it the value hello world. Now we've created our string variable txt, let's look at what we can do with it. We can first find the length of our string by using the len command. So I'm going to type print so we can output its value. And then we can use len to find the length. And then txt is the name of our variable. So len, then the name of your variable, will give us the length. In this case it will be 11, as there are 11 characters, including the space, in our string. There we go, we can see 11. We can also have several other functions that we can use on strings. The first are upper and lower. So if we type the name of our variable, this is what we're acting on, and then the command upper with some parentheses. This will convert our string txt all into uppercase. So let's run that, and we can see that now it's all capitals. Again, we can do the same sort of thing with lower, and it'll get rid of those capital letters and make everything lowercase, as we can see here. We can also use the strip command. And what this will do is it will remove white space before and after any words in our string. So if I add, say here and here, a series of white space, when I run this strip command, it will remove that white space for us. And we can see there's no white space at the beginning of our string when we print it. We can also now join two strings together. So let's replace this first string with just hello. And I'll include a space at the end. And I'll call our second string can be world. Now, if I want both of them together, I can say our new string. All our variable names can't include spaces, so generally we'll use underscore. And we'll call it txt, and then we use the plus symbol to join the two strings together. And we can add our second string. And now, if I print our new string, we'll see that it'll say hello world. So let's do that. You can see here, we've just printed hello world. So we've combined those two strings together. We can also use a replace command. So if I type txt.replace, and I'm going to put a print at the front of here, we can now replace something within our string. So we'll start by typing the word that we want to replace, and I'm going to replace the word world. And this is case sensitive, so make sure you get it right. And now we're going to replace the word world with the word universe. So we type in the word we want to replace and the word we want to replace it with. And now our string will be hello universe. But I need to first turn this back into hello world. We can also add a third value to this function if we wish, which will be a count of the number of times we want it to be replaced. So if we have a string with lots of occurrences of, say, the letter A, and you want to replace just the first 4 with a different letter, then you could put comma 4 at the end and it will replace the first 4. We don't have that here, so we're not going to use it. So let's run this code, and we can see now we've printed hello universe instead of hello world. Now finally, what we're going to do is we're going to look at how we can change the format of our strings when we're printing them out. So first I'm going to change this string to say my age is, and then I'm going to put a placeholder, which is these curly brackets here. And I'm going to create another variable, which I'm going to call age, which is I'm going to set to 25. Now I'm going to print out txt, I'm going to put .format after it and some round brackets. Now in these round brackets I'm going to put the name of the variable age. So this means that it's going to replace this placeholder with the age variable and convert that into a string for us. So now when I run this, we'll see it says my age is 25. We can have multiple placeholders within our string. So for example, I put a second placeholder here, and I'm going to put month, and this one is going to be January. And now I want to put them in order. So I'm going to put age, comma, month, and this will fill in the placeholders with these variables in that order. So let's run this, my age is 25 and I was born in January. So that's filled those two in. If you don't want to be so specific with where you put these in here, for example, if I want to swap them around, we can also index our placeholders. They count in order, so this will be index 0 and this will be index 1. Or if, say, I want to use the same variable more than one time. So if I then want to say I am, say, 25 years old, at the end, I want to use the age placeholder, which will be index 1 here. So I can put 1 here. I was born in month, so I want to put a 0 here, because this is the 0th index. Python always counts from 0, so we go 0, 1. And then I want to put the age index again, so I'll put a 1 in here. Now when we run this, it'll say my age is 25, I was born in January, I am 25 years old. So let's run that. And we can see that has worked. Excellent. Now let's get rid of this and make this a little bit easier to read again. There we go. Finally, to do with strings, we're going to look at how we index them. To index a string, we can reference a certain part of it. So if I want to print, and I just want to print, say, the last 2 letters, we're going to type the name of our string and follow it by some square brackets. And this is where we're going to put our indexes. So to print from the beginning, we leave it blank, or we could put index 0 here if we chose. And we print from this start index to this end index, which is a count of each character in our string. If I just want to go from the end, I can go, say, -2 here, and this will count backwards, and it'll go up until the last 2. So this will print my age is. If I want to start from and only include 25, I can put a -2 here. -1 would do this, -2 will include the 25. We can run that just so you can see. And we can see that 25 has printed out. If we're doing numerical, so for example, if I want to include my age, I want to start at 0, then we're going to count 1, 2, 3, 4, 5, 6. And I'm going to end up putting, so 0, 1, 2, 3, 4, 5. And I need to put 6 because it starts here and goes up to here, but it doesn't include this final index. So remember, we start at 0, 0, 1, 2, 3, 4, 5 is what we want to show. And we have to go 1 higher to 6. So this will print my age. There we go, as we can see. So that's how we index our strings. We're now going to look at if statements. An if statement is a way of doing a logic test within Python. There is a series of different logical operators. There is equal to, which is 2 equal signs. We have greater than, less than, greater than and equal to, less than and equal to, or not equal to, which we do with an exclamation mark and an equals sign. So let's start by creating our first if statement. This will say if, now we have our logic test. Let's say 10 is bigger than 4. Then we put a colon. Come under, and we have to tab in. So Python doesn't have curly brackets around statements like other languages do. Instead, it uses indentation. So we have to keep, within our if statement, we have to keep a consistent indent. Okay, now we've put what we want to happen if this condition is true. And I'm going to print hi. Now we can run this code, and since 10 is bigger than 4, we will see hi print out. we have to be very careful if we're using strings, integers, or floats, because you can't do a comparison between, say, an integer and a string. This won't work. As we can see, nothing has happened. So we know that this doesn't work. So let's now put it back to something that will. And let's create a few variables instead. So let's set a equals to 10, b equals to 2, and c equals to true. We'll have our Boolean variable here. So we could replace this with a and b, and this will work. And we can say hi. If I swap this around to be less than, we'll see that this will no longer say anything at all. There we go. If I set this less than or equal to and replace b with 10, that's not what I wanted to do. Okay, I'll set them both to 11. We'll see that this will work. If I get rid of this equal sign, it will no longer work, as we can see. Now let's do a direct comparison. So we want to check if, say, c, the Boolean variable, is true. We do that by typing c double equals true, and then we'll print hi. And it is true, so we can print hi. We can also check if c is not true. In other words, if it's false, we can do it using the not condition. And again, we can see that that didn't do anything because it isn't true. There's also some conditions we can use on strings. So if I write another string, and if I want to check if something is in our string, so if, say, the word hello is in our text, we can use the word in. So this will check if hello is in our string txt, and if it is, it'll print hi, and if not, it will do nothing. So let's run that, and we can see it's printed hi because hello is in our string. If I put, say, the letter Z here, so it's checking if there's any Zs in our string, we're going to get nothing because there's no Zs in our string. We can also add a not here. So we can say not in if we want to check if something isn't in our string. And again, we can run this, and this will now work because Z is not in our string. We can also add some extra ifs to our if statement. For example, if I want to now add an or, almost, I can type elif. So I could put p in our string, and we can have print p in string. And we're going to change this to help world, or help the world, and Z is still not in our string, so this one hasn't been met. Now if this one isn't met, it will check this one, and if this one isn't met, it'll do nothing. So let's run this, and it said hi, sorry, because this one's been met. I want to change that back to in. And now when so this is a capital P, so that isn't in our string, it's case sensitive. So lowercase p, now that second condition will be met and it'll say p in string. Finally, if we want to put if none of the above are true, we can, by the way, we can put as many elifs as we want. We can put an else. And now else doesn't have any condition, we just put a colon and again an indent underneath, and I'm going to print neither P or Z in string. And I'm going to replace that again with a hello. So our P or Z neither of them are in our text anymore. So we're going to check this one. This isn't going to be met. Going to check this one. This one isn't going to be met, which means it'll do this else. So let's run that. Neither P or Z in string. Now let's check what happens if we have something where both conditions are met. So we have this E and we have an O in our text. So let's see what will print out. It is just hi. And this is because this first condition is met. So remember with if statements that once one of the conditions is met, it will not do anything else. This is an else if. So if this first condition is met, it will skip the rest of this if statement. If you want to check both, and if both are true, both happen, you can include that here by going and O in txt, and then it'll check both conditions, and if both are true, do it here. However, if you want both to be checked individually, then you would require a second if statement here, like so. You can also include nested if statements, which is where you've included an if statement within the block of an if statement. Next, we're going to look at how we create a list in Python. So lists is the first data type we're going to look at, where we can collect many variables within one Python object. A list both has an order and is indexed and is changeable. So the variables within our list all have a specific place, and we can change our list. So let's create our list by calling it a list, and we do that using these square brackets. Inside the square brackets, we can then specify the elements of our list. For example, the integer 1, a float which is going to be 2.4, and a string which is going to say hi. So each element in our list is separated by a comma. And similarly to how we index the string, the index for each element in the list begins in 0. So this one's going to be index 0, this is index 1, and this is index 2 in our list. So let's look at what we can do by indexing this list. I'm going to print our list, and then we're going to put these square brackets at the end of our variable name and include the index we want to reference here. So if I print list 0, this will print this first element in our list, and it's index 0, which will be number 1. And we can see that number 1 has printed. Let's zoom in a little bit. Now we can change this to be, say, index 1, which will print 2.4. And we can see that that has also worked fine. We can also print a range within our list by using a colon to separate it. So we can say print from index 1 to the end. By leaving either side of the colon blank, we can say up until the end of the list, or from the beginning of the list up until, say, index 2. Remember, this index isn't included. So if we go to index 2, it'll only include 0 and 1, so it'll be 1 and 2.4 that are going to print out in this case. And we can see that that's true. So that's our slice out of our list, which we have taken out by indexing it. Using indexing, we can also change the value of element in our list. So I can start off by printing out our list. And now let's access an element, let's say element 1, which is going to be our 2.4, and we're going to assign this to the value of 42. Now, if I print out our list again, when we run this code, we'll see that this list prints out, and then we print it out again, but this element has changed to 42. So let's run that, and we can see we have it here changing to 42. So that's how we change the value in the specific element of our list. Again, a bit like we could with lists, with strings, we can use the in and not in operators in if statements to check if something's in our list. So if hi is in our element list, our variable list, print hello. That shouldn't have a capital, there we go. So now when we run this, it'll print hello because hi is one of the elements within our list. We can also look at some properties of our list. So we can print the length of our list, a bit like we could with our strings, and this will print how many elements that are. So in this case 3. We can see that 3 has printed out here. We can also insert, remove, or append items to our list. So we can do that by typing list, which is the name of the variable which is holding our list, dot append, and this is going to add something at the end, and I'm going to append true, a Boolean variable, and now I can print out our list, and we can see that true has been added as a 4th element to our list. We can also insert something at a specific point in our list. So we want to tell it what we want to insert and where we want to insert it. So I'm going to insert this in index 2, which is the 3rd place within our list. Sorry, this is the wrong way around. So it should be 2 and true. So this is now going to go to index 2 and insert the variable true. So let's run that, and we can see that true has been inserted here in the correct place. We can also use remove, and remove will take out a specific element of a list. So if I replace this with remove, we can type in what we want to be removed, for example, the number 1, and then when we run this, we can see that number 1 has been removed from our list. We could also remove something from a specific index by using the pop function. So we can type pop and then index 1, and this will remove 2.4 from our list. So when we run this, we can see that 2.4 has been removed from our list. We can also join multiple lists together. So I'm going to create a second list. I'm going to call it shopping. And in it, I'm going to put eggs, milk, and cheese. Now, if I want to join these two lists together, I'm going to call it a new variable. I'm going to call it a new list. It's going to be list, and then I'm going to add shopping. So it's a bit like how we concatenated strings. We're just going to join these two lists together. I'll just take the elements of this one and stick them at the end of this list. Now, when I print new list, we can look at this, and we can see that it's just added eggs, milk, and cheese to the end of our list. I'm going to get rid of this, and this, and this, and I'm going to show you how we can sort our list. I'm going to add something else in here. I'll add in some ham. And let's add in some bread. Now we might want to now sort this list into ascending order. Just a speech mark there. And I can type shopping. Can I keep the same name? Equal shopping.sort. Like so. And now I can print shopping. And it will have been sorted. So we can see that bread alphabetically comes first, then it goes cheese, eggs, ham and milk. So this is now in alphabetical order. We can also change the order it sorts into descending order, or backwards alphabetical order, by typing the words reverse equals true, like so. Now, when we run this, we can see that it's now in the other order. So now let's move away from lists and look at the next type of data structure which can hold multiple variables, which is a tuple. A tuple is a bit like a list, but it can't be changed once it's been created. And it'll keep its order, but it'll be indexed like a list. So if you want something that acts a bit like a list, but you don't want it to be able to be changed, then you can create a tuple. So I'll create a variable called myTuple, and I'll do that using some round brackets. Now I can specify its elements, say 1, 2, 5 and 7, and I can index them like I had with my list. So for example, I can print myTuple, and let's say index 1 will be the number 2. So let's run that, and we can see that the number 2 is printed out. Now let's move away from tuples and look at sets. So sets come from set theory in maths, and if you have never heard any of that, then that's okay. But a set is an unordered and unchangeable set group of variables, which means that we don't have an index for them. There isn't a specific order for our set, and we can't change what's in it. However, we can do lots of useful and very quick operations by using sets in Python. So we can create a set, so I'll create something called mySet, which is going to be created between these squiggly brackets. And in my set, I'm going to say include 2, 4, 6, 8 and 10. The even numbers. Now we can add okay, so now what we can do is we can do some operations on these sets. We can add an element to the set if it's not already included within the set. So if I type mySet dot add, let's call it 12, and then I can print my set. Let's see what we get. The set is 2, 4, 6, 8, 10 and 12 is what's included. We can also remove something if it's in the set, so I can remove the number 2. So that's 8, 10, 8, 4, 10 and 6. As you can see, there isn't a specific order to the set. It won't maintain its order, and we can't index our set. If I go back to add and try and add 2, we'll see that absolutely nothing happens because 2 is already included in our set. So we still just have 2, 4, 6, 8 and 10. And again, we can see the order has changed, but our set doesn't keep a specific order. Now let's look at a couple of the set theory functions that we can use. Some of the basic ones is union and intersection. So to use these, we want to create a second set. And I'm going to create as my second set. I'll call it my set 2. And in this one, I'm going to include the multiples of 4. So I'm going to go 4, 8, 12, 16. Now, I'm going to print my set. I'm going to print the union by typing my set.union my set 2. Now when I run this, we can see our code includes 2, 4, 6, 8, 10, 12 and 16. It doesn't include duplicates, so 4 and 8 were already in our set, so it's only added to 12 and 16. So it'll just take and give us exactly once every element that's in either of these two sets. We can also do the other operation, which is intersection. Now what this will do is it'll take something it'll give us a set which contains everything that's in both sets. So we have 4 and 8 which are in both sets. So when we run this, we'll have a set which contains 4 and 8. Finally, let's look at our final type of structure which can hold many different variables, which is called a dictionary. Now a dictionary is unordered, so we don't have the same indexing as we do with lists and strings. And each element will be assigned to a key, so we can have a named key which can be used to access each element within our dictionary. For example, let's create a dictionary called person, and we create our dictionary by using curly brackets. Then we type the name of our key, which is going to be within single speech marks, colon, and then the value. So our value for age is going to be 25. Then we separate each key with a comma. So our name can be Dave, and our country can be, say, United Kingdom. So now we have created our dictionary, and it's got 3 keys: age, name and country. Age has been assigned to the value 25, name has been assigned to the value Dave, and country has been assigned to the value United Kingdom. Now let's look at how we can access these values within our dictionary. So we can print, and a bit like how we indexed, we type the name of our key. So we're going to type person, which is the name of our dictionary, and then in here we're going to type age, which is the name of our key, and we'll see that 25 should print out, which it does. Again, we can do the same thing with name, and Dave will be printed out. We can also edit the value of that index. So if we've got that person's name wrong, say, and we want to change it to something else, like Jane, we can do so by typing name and then giving it its new variable. Now, if I print out our dictionary, we'll see that the name has been changed to Jane. So we can see country is the UK, age is 25, and our name is Jane. So we have changed the value at that key by accessing it like we have above. We can also do a few other things with our dictionary. Again, we can do the length of our dictionary. So we can type len person, and this will be 3 because we've got 3 entries in our dictionary. So let's run that, and we can see its length is 3. And finally, we can use the pop function like we used before. So we can type person.pop, and inside we need to type the key for the element we want to remove. So if I want to remove country, I can use the pop function, and then I can print out our dictionary, and we'll see that the country area or the country element has been removed. As you can see, we've just got age and name left in our dictionary. So that's everything on dictionaries and how we can use the different methods we can use to store multiple variables. Next, we're going to take a short detour and look at how we can collect user inputs into our program. There's a difference between Python 2 and Python 3 in this. I'm using Python 2, so I'm going to be using the command raw input. In Python 3, it's just called input. So let's create a variable, and I'm going to call it user, and it's going to be a raw input. And now I need to type a prompt for the user. What is your name? Now this prompt will be displayed on the command line, and then it will wait for the user to enter a value and press enter. And what they enter will be assigned to the variable user. And now what I can do is I can print hello. And this is also going to start off automatically being a string, whatever they type, even if it's a number. So remember, you might need to convert to a different value if, say, you want their age and you want it as an integer. But it'll let me easily combine the strings by concatenating them like we did before. And we'll say hello plus user. And this will say hello and their name. So let's run this code and we'll see it says what is our name. We're going to type in Dave and it'll say hello Dave. I didn't put any spaces in. If I'd included a space here, then there would have been a space and it would look a lot much neater. There we go. So that's how we can collect some basic user inputs in Python. Up next, we're going to look at how we can use a for loop in Python. So a for loop is a way of moving through a series of items and doing something each time. So to start with, I'm going to create a list, and it's going to be shopping again, and I'm going to have eggs, milk, cheese, and bread. I'm now going to create my for loop by typing for, and now we say what we want to loop through. So we want each shopping item, so I'm going to say for item in shopping. So in each of these items within our shopping list, it's going to be assigned to the value item. We're going to then run some code. So we're going through each one of them that's in the shopping list, which is the name of our variable. And then we can use that item variable within our for loop here to do something with it. So I can say print you need plus item. And this will print you need the item, and it'll loop through until it's gone through every element within our shopping list. So let's run that. You need eggs, you need milk, you need cheese, and you need bread. Again, I didn't put space. So we can see that has worked here. We can also create a for loop using the Python's built-in range function. So I can say for number in range. Now we need a start, stop, and a step. So the start will automatically be 0 if we don't set it, but otherwise we'll set it to say 1. So this is where we want to start counting from. I might want to go up to say 10, and I might want to go up in steps of 2. So this is the start number, the stop number, and it doesn't include this 10. So it'll go through all of the numbers, not including this final number, and the size of the jump. Again, we put a colon and an indent, like we did for if statements before. And now I can print, say, the number, and we'll see what this is generated. So we'll see 1, 3, 5, 7, and 9 were all printed out. So that's a way of getting it to loop through a series of different integer numbers within our for loop. We can also create a while loop, which is the other type of loop that you have in Python. And this is used when you don't know how many times you need to loop through something, and you're waiting for a condition to become true or false. So, for example, while I'm going to create a variable I in a second, and we're going to say while I is less than 10, let's put I equals 0 here. And then while I is less than 10, we're going to print I, and then we're going to put I is going to become 1 larger. So this is going to keep incrementing through I, and we can run this and we'll see what it outputs. And we can see we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because on the lifetime, I was 9, it's printed 9, it's become 10. This condition is no longer true, so it's finished and carried on. There is also some other conditions that we can include in our while loop, which is continue and break. So we can put, let's say, an if statement in here, which is if, say, let's put it a bit higher up. So if we don't want to say if I remainder with 2 is equal to 0, so this means if I is divisible by 2, then we can continue, and this won't end the loop, it'll just jump back to the start and not do the rest of the loop, which means it will skip this print part of the loop, and also this increment part, which will break it and we'll get an infinite loop, which is something that you do not want, so we need to include that in here as well. So let's run this. Oop, there's the wrong indentation here. So let's correct that. And now let's run it. And we can see we've got 1, 3, 5, 7, and 9. So we've skipped every time that I is divisible by 2. We could also use break here. And I'm going to set this to 1 just so we get something. And what this will do is when this condition is met, it will just end the loop and stop it there. So let's run that, and we can see that 1 happened. Then when it went, I got incremented by 1 to become 2. That was met, this condition was true, and then it ended the loop. So that's everything we want to talk about on while loops. Now let's look at how we can create a basic function in Python. So now let's create our first function in Python. We can do this using the def. So we type def to define our function, then we type our function name, I'm going to call it print stuff. We put some brackets, and in here we're going to include the variables that we want to pass in. So for example, I'm just going to call the variable stuff. And then in our function, I'm going to print stuff. Again, we've got this colon and everything needs to be indented the same amount within our function. Now, further down, if I call the function print stuff, and I type, say, hello world, this is an overly complicated way of printing hello world. So let's run it. And we can see that we've printed hello world. What this is doing is we're taking the function print stuff, which we've created up here, we're calling it, we're passing in the variable hello world as stuff, and then we're printing it. This is also a good point to discuss the difference between a local and global variable. If I create a variable up here, I call it, say, I, and I make it 2, this is a global variable, and this can be used everywhere in our French program. So if I want to say print I within our function, it's been declared before our function, so this will work. We can see 2 has been printed here. However, even though stuff has been declared as a variable here, this is a local variable unique to that function. So if I try to say print stuff here, this is in the global scope of our program, not within our function. This variable will not exist, and this will cause an error. As we can see, stuff is not defined. Next, we're going to look at a different type of function where we're going to want to return something. So let's create our function, and I'm going to call it sum. And we're not going to know how many numbers we want to sum in advance. So what we're going to do is we're going to type a star, then the name of our variable, which I'm going to call nums, and again put our colon. This star tells Python we're going to have an unknown number of variables being passed into our function. Since we want this function to send a value back after it's been run, we're going to include the return statement, and then I'm going to call it, I'm going to sum the nums. So I'm going to sum all of the variables that are passed in, and I'm going to pass that back. Now let's look at how we're going to call this variable. I'm going to create a variable called summed, because we need somewhere to store the answer from this calling this function. Then I'm going to type sumnum, which is the name of our function. And now I can give it as many variables as I want because I have that star. So I'm going to put, say, 1 to 6 in here. And then finally, I'm going to print out the answer that it gave us by printing out the variable summed. So let's run this. And we can see that the answer 21 has been printed out, which is the sum of all of these numbers. I could instead have created, say, one variable, call it nums, and instead put all of these in a list, like so, or something along those lines. This isn't going to quite work. There it is. And we can see that that's also printed out to 21, but it can be sometimes easier to pass in as many variables as you need by using this star. If I wanted to, say, have two variables passed in, I could say put A and B as the names, sum A and B using this sum function, and then just put them in order, so 1 will become A and 2 will become B. And again, I can run this. So I did this extra brackets in the sum, which you've got to enclose all of the things to be summed in brackets within the function. And we can see that the answer is 3. So that's us completing that sum function. Next, we'll look at how to do a try and except block within Python. So we can, if we're not sure if something's going to work, we can type try, colon, and then some code. So I could put, say, 10 divided by 0. And this is definitely going to break, which means it will raise an exception. But if we don't want our whole code to crash when we can't divide by 0, we then include a try except block, where we put this try, colon, indentation, what we want it to try, then an except, and you always need the pair of them, a colon underneath indentation, and this will stop our code crashing when we encounter an error here. So let's run that, and it'll tell us that we can't divide by 0, because just this will raise an error, so it's going to trigger the except block and do this code instead. That's all there is to try and except blocks. Finally, we're going to look at classes in Python. So to create a class, we're going to type the word class, and then the name of our own class. So a class is a way of having a collection of variables and functions which can be used many times over for different objects, and each have individual different values. So for example, I'm going to create an employee class, and in it I'm going to create a variable name, and it's going to be Dave, and I'm going to create a variable age, which is going to be 25, don't need strings there, and I'm going to create an employee ID, and that's going to have a value of 1. Now let's create an instance of our class. So the class currently isn't doing anything, and we want to have several instances of our class. Each instance is a different version of the class, which will have its own set of these variables that we can change independently. So for example, I can create an instance of the class for person 1 by typing p1, and that's going to type equals employee. And that's me creating our instance of our class. At the moment, that's not very exciting. I just need to include some brackets here. But it'll let me do something like print, and now I can access any of the variables within our class. So p1.name, for example. I need to do p1 because this is the instance I'm looking at, and then the variable within our class. So if I run that, we can see Dave has been printed out, and that's the name. We can also access those variables and change them. So we can say p1.name equal to Jane. So now, if I print p1.name, it'll now be Jane. And the advantages of a class is I can create a second instance. So for example, p2 is also an employee. And if I print p1.name and p2.name, what we'll see is this one will be changed to Jane, but this one will remain Dave. So they're both separate instances of this class, Jane and Dave. Now let's look at how we can initialize our class a bit better. And each class has a special method called the init function. So we can create that by typing __init __ and some brackets. Now inside the brackets, we're going to have a few things that we need to pass in. So this will be going to be, so we need a def here because it's a function. First, we need to pass in self. So it is part of itself. So this is going to be for each instance that we're creating. On creating that instance, we need to know what instance that we're working with. So we're going to pass in self, then we're going to pass in name, age, and ID. Now we're going to say self.name is going to be equal to the name that we pass in. Self.age is going to be equal to the age that we pass in. And self.employee ID is going to be equal to the ID that we pass in. Now let's create another instance of this class by typing p1 equals employee. And then this time, inside the brackets, we're going to need to pass in the variables name, age, and ID. So the name we're going to pass in is going to be Dave. The age we're going to pass in is going to be 25. And the ID we're going to pass in is going to be 1. Now, when I print p1.employee ID, we'll see that it'll print out 1, and we've created an instance of our class. Oops, sorry, I've missed out a colon by here. There should always be a colon at the end of the declaration for each function. And I've also made a right mess of this. I should have included an indentation there as well. Right, so now let's try running that again. There we go. So we've now created an instance of our class and given them an employee ID of 1. We can also create some functions within our class. So to do that, we're going to create another function here. I'm going to type def salary. And inside salary, I'm going to need itself. And I'm going to return self.age age, which is going to be the age of the person whose instance this is. So for this instance, which is P1, we're going to take the age, and it's going to pass that into this function when we call it, and it's going to take that, and I'm going to multiply it by their employee ID. So that's going to take the value of the employee ID variable for this instance of the class, and we're going to multiply those two things together, and we're going to return that. So if I now type p1.salary, I can now call that, and it will then multiply 25 by 1, which will just print 25. And I've missed the colon again, so we'll fix that. And there we go, we've printed 25. If I then change how I've initiated this class, so I give them an employee ID of 2, their salary will go up to 50, which we can see has been reflected here. Again, I can create a second instance of this class, like so. And now again, when I initiate it, I can give this person the name Jane. This Jane can be a bit older, she can be 30, she can have an employee ID of 4. And now, if I want to look at Jane's salary, I can just change this to P2. And I'll call this code again, and we can see that she has 120. Finally, we're going to look at how we can do some inheritance between classes. So you can assign a parent class to a class, and then the new class will also inherit all of the values and functions from a parent class. So if I create a second class and call it person, and then I've included these brackets here in employee, and in person I'm just going to create a variable, and I'm going to call it gender, and I'm going to default it to female. Now, if I include person here, that's me telling Python that employee is inheriting the features of the class person. So if I now come down here, and instead of typing p2.salary, I'm going to type p2.gender, what's going to happen is I'm going to have a gender value inherited from the person class, and it will say female. So let's run that, and we can see that it says female. So that's inheritance between classes. The final thing we're going to quickly look at in this tutorial is file I/O. So that's file input and output. We'll cover a bit more detail on some other methods of doing this in our NumPy tutorial, which is one of the most important modules that you can import into Python. So stay tuned for that in the coming weeks. But for now, let's have a quick look at how we can do some file I/O in Python. So to start off with, we're going to create a name for the variable which will hold our file. I'm just going to call it file, and we're going to say it's going to be open, and we need a name of our file. I'm going to call it temp.txt, and we can now choose three modes. We can choose read mode, which will just let us view what's in the file, but we can't change it. Write mode, which will let us overwrite what's in the file, and we can just put whatever we want into the file, but it will replace whatever's there. Or append mode by putting an A, and that'll take whatever's in the file, and then we can add extra things afterwards if we wish. I'm going to open this file in write mode. We can also include a delimiter here if we choose. Now we can take our file, and we're going to type .write, and we're going to put whatever we want to write to our file. So hello world. And finally, we're going to close our file so we don't corrupt it. And that will also free up some memory. So what we're doing is we're opening the file, we're writing to it, and then we're closing that file. So let's run this code. So we should have included some quotation marks around the W there. So now we can run this code, and now that's run. And if we go into our file, we can see this temp file called temp. It's a text document, and inside it we will see hello world. Now, if I run this again, we'll just open our file. We're going to replace what's in it with hello world, and we'll close it. So I'm just going to close that file. So let's run it again, and we'll see that inside the file we still just have one hello world. If I now come in here and change this to an A, this is putting it into append mode. So we can now close that, run this again, and we should see that there'll be two hello worlds in our file. Hello world, because we're just appending to the end. So that's the difference between the append and write mode. We could also put it in read mode, where we won't be writing anything to the file, and we could just print out what's in it. Anyway, that's everything we want to show you in this Python tutorial. We hope you found it useful. It's been quite a long tutorial, but if you've enjoyed it, make sure you leave a like, subscribe to our channel, and leave a comment. But for now,